Look at it run. Hello, ladies and gentlemen, and welcome to the Highcon Beam live event. I'm very happy that you joined us today. My name is Ben Shitrit. I'm the VP of Marketing for Highcon, and we are going to show you today the Highcon Beam digital cutting and creasing machine for mainstream production. Today I have with me Moti, R&D engineer for the Highcon Beam that will operate the machine. And I want to start by thanking you all for joining this historical and very exciting event. We have over 300 people joining in from over 40 countries. And this is a live event, ladies and gentlemen, so we want you to be a part of this event. If you are sitting in a Highcon location around the world, we have several of those, please now, this is the time to select a word, your slogan that will incorporate into the jobs that we are running. And actually, before we start, I want you to know that we have a way to interact. If you look below here, not in the screen, but below the screen, you have a box allowing you to ask questions. You can actually submit questions live during the event, and we will use them throughout this discussion at the end and answer your questions live. What you actually saw, just to get us started, is the Highcon Beam running this job, the energy bar job, a standard packaging job, 9-up, in a speed of over 3,000 sheets per hour. So the Highcon Beam is a completely digital machine running at very high productivity. And we're going to show you today all about this machine, how we operate it, what it can do, what are our plans for it. But in order to start again, I want you to hear for a second time the music of the Highcon Beam in action. Because you know, there is nothing like getting a gut feeling of what the machine can do and hearing the speed and productivity of a digital solution that is not for short runs, not for specific niches, but actually for the mainstream of production in packaging and in commercial application. So actually ask Moti to run a few sheets of the job again so you can get a sense of production of 3,000 sheets per hour. And then we'll go and watch the machine step by step, learn about its capabilities, learn about how we set up a new job from scratch, and watch the entire process of creation of a new packaging job. A process that now takes hours, days, and even weeks will be done in minutes. Finally, when we complete reviewing the Highcon Beam, we'll have Brian Sidebottom from Glossop Cartons, the world's first user of the Highcon Beam, who's currently beta testing it, to answer our needs. Yes. So, with a speed of 3,000 sheets per hour for this job, running a full pallet is a matter of less than an hour. And actually, what's amazing about this new technology is that from the moment you have the file, let's say for this job, for the moment you have a file into production of tens of thousands of units, it's just minutes. So the machine started to run again, and we'll ask Ophir, our cameraman, to show you the main components of the machine. You'll be actually able to see the most important part of the process, and then we will walk you through each component one by one, explaining the different elements. You can see the sheets coming into the machine, being creased, and then cut by a laser process, all of which we will show you step by step throughout this event. You can actually see now very clearly the high-powered laser that is cutting the sheets very, very fast, achieving high quality in a totally digital process. We'll let you enjoy the digital cutting and creasing and the sounds of the beam, and then we'll start with our planned agenda. Actually, in several minutes, less than 5 minutes since we began, we already produced in a digital process thousands of boxes. Short run, medium run, you tell me. But what's digital all about? What is the story about digital? So first and foremost, before we go to the technology, before we go to the elements that comprise our machine, let me tell you a little bit about the Highcon Beam. So Highcon, the company was founded 6 years ago with the vision of turning cutting and creasing into a completely digital process. We started with the Highcon Euclid, our first generation machine that is now installed in over 30 customer sites around the world. And we saw immediately that our customers are using it for short-run production of packaging. Areas where cost saving from a digital process were very, very advantageous. So our customers started working by taking their short runs from analog cutting and creasing, moving it to the Euclid. Soon after, we found out that commercial applications like greeting cards can also be produced. Then our customers identified that there is an opportunity to create what we call high-value application with special cutting, intricate cutouts that only laser can achieve. And we see our customers doing it in a wide range of segments, in packaging, in commercial, in greeting cards, and all the way to window displays, all live projects that our customers did. But one thing that our customers told us is that for standard jobs, standard packaging job, standard commercial print jobs, they would like to use our technology to longer runs, not only limited to short run small quantities or special high value application, but actually to address the challenges and complexities of cutting and creasing in a production environment. And the key to do so was to launch a machine that will bring those capabilities, those technological capabilities, to long runs, to the mainstream of jobs. And the main element of being a digital process, as the Highcon Beam is to control the entire process directly from the file. So what we'll actually ask Moti to do now is to show us the entire process of taking a new job, a new file, and setting up the machine. What Moti is about to do might seem very simple, but it actually replaces a very, very complex and long process. Moti has the file from the customer, from your customer, and needs to create the entire creasing and cutting job. But this doesn't replace only what you do today on your conventional system. It replaces another function, the die making process. So actually Moti, who's not a die cutter operator, he's actually a mechanical engineer, he's going to perform now what is done by the die maker and by the operator of your cutting and creasing. Let's go and see the user interface. So in order for Moti to have all the advantages of our digital process, he needs a very clear and very simple way of operating the machine. And this is our user interface. What you see now is the previous job that Moti ran, the energy job, the energy run job. Moti has now, in a click of a button, uploaded a completely new job. The user interface will walk Moti through the stages of setting up this new job. But all the parameters he needs to have in order to create this new job are stored on the machine. In order to begin the process of creating a new job, Moti will need to mount a new foil on the machine. So this is the foil that will start our process. And while Moti is loading the new foil and preparing for the new job, let me walk you through different elements of the machine, and then we'll get back to Moti when something new is happening. So actually, our customers all over the world are using our technology in order to change the way their business is managed. Imagine that you have a digital solution for cutting and creasing. You can actually decide to move certain amount of jobs from your analog machines to the digital machine, to cutting and creasing on a Highcon machine, and actually reducing costs, reducing time, giving better services to your customer. This is the basic element of cutting and creasing. Then you can find new ways of interacting with your consumers, with your customers, new supply chain ways to offer solutions to your customers. Your customers are now buying more than they need. They can split it up to multiple runs. Your customers now are buying to stock. You can produce on demand. Your customers are requiring shorter turnaround time. You can do that. Why? Because you go to a digital process without tools with much faster turnaround time. But then you can take an application that is simple and add special decoration to it in the laser, and we'll discuss this later on. This is what we did with the Beam. We decided to have a machine that is compatible with short runs, but can also bring you a solution for medium run length, being more cost effective and more fast. In order to do so, we had to completely rechange the way of thinking. We have to start from scratch and looking at how we take our technological building blocks that are already implemented in the Euclid and adding them into a production speed machine, into a machine that is compatible to go into more industrial processes, more industrial jobs. We started by redesigning the feeder. The feeder of the beam is much more robust than the feeder that we used to have because it's meant to support a much faster production speed with a much more demanding production environment. So what we did is we combined our understanding of what an industrial feeder needs to look like with the learning of the industry in paper handling. So the feeder is not something that we invented. We just designed a very robust, very solid feeder that can match the capabilities needed for our machine. And we decided to focus on more markets. We decided actually to take our technology with the beam to more industries that require our capabilities. So we said, what is the mainstream of application that will be run on this machine? Folding carton work, so packaging work. But since we saw that we answer a need also in the commercial print market, we decided to add support for paper. So we start the machine paper gamut from 120 microns. So support even paper and sticker stock. Packaging, of course, but in packaging we identified another high value market with a need for differentiation and a need for a solution for short run. And this is why we decided to include support of E-flute, of corrugated board, up to 2 millimeter thick. So actually, this machine supports a huge range of application from 120 micron paper and sticker stock through folding carton and all the way to E-flute like this wine box example that I have here. What about format? So we thought about the most compatible format to match the industry needs. And we know that for packaging, you need wide format. You need to be able to support B1 format, 42 inch, or 106. Why is that? Almost all printing equipment that exists today is in that format. In packaging, this is the dominant format. And we wanted to be compatible with the existing workflow. We didn't want our customers to need to change the way they print today. So the machines support this format. What about digital? You will hear from Brian, and you can see in our customer base that combining digital printing and digital finishing can be very powerful. So this machine is going to work, and in our future install base, we see people, customers, that will use digital printing in a smaller format, 76 centimeters, 29 inch B2. But actually, we saw an emerging trend in Drupa 2016 of wide format B1 digital printing presses, be it Landa, Heidelberg, or KBA. And actually, we have a machine that is compatible with analog printing processes today, but also with digital printing processes of today and of tomorrow. This means that this machine will find itself in a digital production environment, completely digital, in an analog production environment in printing, and in combination of both. And this is exactly what we see from our customer base. So Moti is continuing with the preparation of the job, and now is moving to the Dart station. Let me talk with you a little bit about the Dart. The Dart is the core of our technology. What we have actually is not only the first digital cutting and creasing machine, but a completely unique creasing process. We decided that in order to develop a digital machine, we must rethink of the way creasing is done. And we developed what we call DART, Digital Adhesive Rule Technology, which is one of the most integral parts of our technology. We looked at the need. The need is to create a proper crease. The need is to create a crease that is compatible with the quality standard of today, of your machines, and is compatible with your customer's need. The need to run the machine through folding gluing, but more important, through automatic filling lines. So actually, our process takes the crease, changes the way it's done, but the result is identical in terms of performance. And how we do that? First, we have our upper drum with the foil that Moti mounted. Now we are preparing it for the next job. We are treating it before we start what we call the writing process. So while it's being treated, let me show you our registration table. Actually, in every machine that Highcon produces, but especially the Highcon beam, we understand that 99.9% of what we cut and crease will be printed. And actually, we need a way to align our process to the print. How we do that? We have two ways. First, we have a table here that registers the sheet mechanically. measures the edge of the sheet and registers it to our process. If the printing is accurate and if the printing is consistent on your sheets, that's all that you need. And in most cases, our customers require only mechanical registration. But this is a digital machine, and we want you to have flexibility, and we want our customers to use it in all different ranges of workflows. So we added another capability to optically register. And we actually optically register each sheet before it goes to creasing and before it goes to cutting by reading a specially printed registration mark. This means that even if there is a misalignment in print, if the print is not completely consistent throughout the run, we can adjust our process of creasing and cutting directly to the print, which makes sure that print to cut registration, print to crease registration is as close as it gets to perfect. And this is important because once the sheet arrives to cutting and creasing, you don't want to have to reprint it. You want everything to be ready and run. So in order to make sure that you have all the flexibilities of a digital solution, these two processes are required. Then the next stage is actually creating the creasing rules, we call them. What you'll see in a minute is the writing process beginning. We'll ask Moti to open, so you'll be able to see closely. What's happening now is that according to the file, according to the element of the crease, our writing head will start to move and lay down a polymer on the drum. We're actually, in a sense, creating the creasing rule now on the machine. So what you see is actually our specially designed polymer that is in a consistency of a paste, very similar to a toothpaste, now being laid down on the drum. This is done according to the digital file to represent the areas that we want creasing to occur. But this is not the only component of our creasing technology. What we actually have here is one piece. We have an upper drum, which the creasing rules are written upon, and once completely written, cured with a UV lamp and become hardened polymer. But this is combined with another element that is very hard to see. I will try to show you. On the bottom, we have a counter drum. This is a special counter that we developed with special characteristics that makes it semi-firm. And actually, the creasing process is an intersection and combination of the upper drum with the creasing rules and the bottom drum with the counter. The pressure that is achieved between those drums and the paper results in a proper crease. And it's very important to make this point that this is a mechanical crease. So we're actually creating the effect of a creasing of a crease. How do we know that? First, we have customers all over the world that are already using this. And they have customers that are using it. They're using it in folding gluing lines, but more important, in filling lines, which for us is the #1 testament of quality of our creasing that we achieve. But second, we have a very, very deep technological department in Highcon that is focusing only on creasing and creasing quality. And we found out that creasing is something that you should and can measure. There are ways in the industry to measure crease quality, to measure the different parameters that define if a crease is okay or not. And how do we do that? We compare crease carton and crease paper from our machines versus the same carton, the same substrate, creased on an analog machine. And we try to see first what is the quality and what is the consistency. And what we identified is actually that in most cases, not only that the crease is in the same quality, but actually the results are more consistent. And why is that? The reason that the crease is more consistent is that all the parameters that is needed to achieve a proper crease are stored on a digital file. So Moti is an excellent operator of this machine. But let's say in your factory, you have a difference in your operator between a day shift and a night shift, or between different days of the week. When you have an analog process, the creasing quality is determined by the skills or the art of the operator. We take the art and turn it into science, and turn it into numbers. All the parameters of the crease are stored on the machine, on the computer, per specific jobs. More than that, all the parameters required in order to achieve perfect creasing and perfect cutting of a specific substrate are stored in a substrate profile library. Once you define a substrate once, the elements that are required to to maintain quality are stored on the machine. Next time, when you load a different job with the same substrate, you can go to the same parameters that are already stored. If you already cut and crease the job, and you want in the future to cut and crease it again, all the parameters needed in order to cut it perfectly are stored on the machine. Then, we completed creasing preparation process. Now we have cutting. Cutting is done also digitally by lasers. And in this machine, we have 3 high-powered lasers, each of them 1 kilowatt CO2 laser. Why is it important? Why do we need such high-powered laser? First, speed. The power of the laser allows us to run fast. But second, quality. The stronger the laser is, the more focused and precise we can be. We can apply the right amount of power that we need in order to cut for the right amount of time, cutting the paper or essentially evaporating it without causing any peripheral damage, just applying the right amount of energy that we need. And how fast is this machine? So the machine can run up to 5,000 sheets an hour, which is really, really fast. But the speed is determined first and foremost by the laser. So imagine, if the laser needs to run in a very short line, a very straight line, it runs fast. The more the laser has to go, the slower it takes and the more time it needs to spend on the sheet. So actually, the more complex the job is, the more ups you have on a sheet, or the more complex the decoration, the slower the process is. So in a typical job, like the one that we show you, the energy box job, it will run about 3,000 sheets per hour, even more. In this job, the job that we chose for you today, there is lesser cutting. It's a one-up job, a gift box job, that runs over 4,000 sheets an hour. Actually, when the machine will be launched, this type of job will run up to 5,000 sheets per hour, which represent the higher speed that the machine can get. But we believe from working with our customers that a standard packaging job will be in the range of 2,800, 3,000 sheets on average, and commercial print job can even run faster than that. Finally, after cutting, we have a unique stripping station, the Highcon integrated digital stripping unit that strips all the elements, the internal elements of the job, fine decoration, complex cutting, automatically, without any setup, without a need to do anything, to do any preparation without any tool. So actually, not only that you can cut and crease without a tool, you can actually save another stripping tool that makes the complex job, the complicated cutting job, much more efficient. Modi, how are we doing with the job?
Well, actually, I think we can run this.
Okay, so I didn't start my clock, but in a matter of minutes, Moti uploaded a new file, actually created the entire creasing plate in our digital adhesive roof technology on the machine, and now he's ready for production. But you might have noticed Moti didn't waste any sheet for setup, because all the information required for setup was on the machine. But Moti, I think it makes sense to cut one sheet or two sheets just to make sure that the quality is okay. So you go ahead and do that. Why is it important? Let's assume we have an analog process, and the job is already here, and the die is already on the machine and set up. And there is a mistake. The die maker didn't do their job correctly. The print made a huge mistake and printed upside down. In a normal analog context, what you will have to do is to choose between one of the two. Either reprint the job or reorder the die. Processes that will cost a lot of money, but even more critical, can take a lot of time. In our case, if Moti did a mistake, Moti never makes mistake, but if the printer makes mistakes, Moti can actually adjust a lot of parameters on the machine. He can change the layout, he can change the imposition, he can change the cutting parameters. So it makes sense for Moti to waste just two sheets and to check the quality. And Moti can do that to check the quality, but he can also do that to prototype. So imagine your customers wants to see a full prototype of the production machine. You can in minutes create a prototype, receive and approve from your customer on the actual final quality, and if they're ready to go, you can start production. So, Modi, what do you think?
We need to move 3 millimeters every side.
Okay. So actually, Moti found out that there is a need to an adjustment of several millimeters, something that goes beyond what you can do with a tool. An analog tool can be moved a little bit, but let's say you have a huge rift. In this case, Moti just goes to the screen and changes the layout, changes the way the tool, in a sense, the digital tool, will interact with the paper. In a click of a button, Moti has made what we call last-minute correction. And now, instead of delaying the process, delaying production, or having the need to create a job from the beginning, it's ready to production. So, Moti, it took us a lot of time to set up this job. Yeah? So I think it's time to run. Now, after this setup process, Moti is ready to run production. And actually, we'll run several hundred of sheets. As the sheets will pass through the machine, we'll walk you again step by step through the process, so you'll be able to see with your own eyes. And this job, remember, runs at over 4,000 sheets per hour, which is really, really fast. So actually, the sheets will end pretty quickly. So what we see, the feeder, the sheets going into the machine. Registration. In this case, the print is analog, so we register mechanically. And then creasing. Each sheet receives pressure from top, from the rule, against a counter drum with our special counter formulation that creates a mechanical crease. Each sheet goes then to what we call the cutting chamber. And you can see the laser is so fast, it's hardly visible, but very, very impressive. Remember, running so fast, so accurately, produces amazing cutting quality. Putting almost no effect on the paper. And in this case, the paper will be left almost completely white. What we're doing now is cutting, but the laser can do partial cutting and can do etching, actually just marking the paper with laser. You can see the job running in production very fast. I love to watch the laser. And this is a completely digital process with a very quick setup, but in a full production speed. So imagine if you have a short run, or even if you have a medium run, you need to produce thousands, tens of thousands, and even hundreds of thousands of boxes. It can be produced in an hour or within a few hours. Not only replacing the production, the cutting and creasing process, but actually replacing the entire cycle of die making, ordering the die, and setup. So Moti, I think this run was enough. Okay? One thing that digital brings besides solution for short runs is the ability to interact with your customers in a new way. So let's imagine today that your customer has made a mistake or would like to add something to the job, to create something different, while the job is already on the machine. Today, it's something that you cannot accommodate. You cannot invite the customer to come and watch the entire correction or creation process on the machine. It will just take too much time. Even when you have the die, you don't want the customer to be on site when you make the preparation. In a digital case, in many cases, this is actually a value that you can deliver to your customers, to the brands. They can actually be a part of the production process and influence it. Why is that? If we would like to create a new creasing matrix or new creasing on the dart system, we can do that in minutes. But if we just want to change something in the laser, in the program of cutting, we can do that literally in seconds. And this is what we want to demonstrate today. We have a completely new data that arrive from our customers, from you. You are our customers around the world. We have a few locations that sent to us a word, the slogan that they chose. They did it just now, less than 30 minutes ago. And we received the file, and we created a new job based on the existing job. And what we want Moti to do is actually load a completely new job. So this is the gift box. But Moti goes, as it is a completely new job, and loads a new file that we received from our designer. The file is based on the gift box job, but actually contains another layer, a layer of special decoration. We call it marking. What we can actually do is, you can see here, we can cut. The laser cuts all the way through. We can partial cut. We can emulate the crease with cutting. But we can also mark. Marking is actually writing with the laser. And our locations have chosen a few words. And we wanted to show you, first, that this is a live event. We wanted to demonstrate that we get feedback from you and incorporate live. But also that changes in the laser cutting are immediate, instantaneous, in 1 second, even with it's a completely new file. So Moti, is the job ready?
Yeah, ready to go.
So in 2 clicks of a button, in less than a second, Moti changed the plan of the laser. In this case, just add in a few words. We'll show it to you. But in other cases, it can be other decoration. So imagine, instead of writing words, you can actually change the decoration. You can add special cutting features. You can actually cut on this energy job box a chocolate when it's a chocolate, and a banana when it's banana. And this is done without any setup on the machine, without any time spent. And we actually took this capability one step further. What you saw now is Moti loading a new job on the laser with a few clicks in a button. We thought, how about automating it? How about letting our customers actually cut different elements, different names on each box in a different way? And we call it variable data cutting. So what our customers will be able to do is actually take a single job, a single structure, and add to it an unlimited amount of cutting, marking, or laser decoration. This will be used for personalization. So imagine instead of printing a name on a package or on a product, cutting it. It will also be used for serialization, taking one product and adding an unlimited amount of different variants to it. And finally, it can be used for security, cutting a specific code or a specific element on each box. So now Moti is actually running a different job with a different element on the machine. You can see that actually by adding more cutting information, Moti slowed down the process a little bit. But in this case, we are creating a much more complex job with more information, with more cutting, and hopefully with more value. Taking the simple box and added another layer of information and value to it. So Moti, after running, can you show us a few samples of this box? And you'll be actually able to see which words. I don't know which words were inputted. You know because you are sitting in our location. The Highcon Beam is the machine that you see in front of you. It's digitally, completely digitally, driven by a file, operated by a single operator, Moti, who doesn't have experience as an analog die-cutting operator. He actually knows about technology, he knows about computers, he knows about engineering, and he knows what it takes to operate a machine like that. Why is that? Because the control over the process doesn't lie with Moti, it lies with the file. And actually, once Moti did what is required from him in operating, and the machine is performing the task, he can move to do other tasks. For example, operating another machine, operating a digital printing machine. And the flexibility of having not only a digital process, but a single operator with a different set of skills can really, really change the way that you are doing things. So, Moti completed the new job, and actually what we had in 35 minutes is one job, the energy box job, running at 3,000 sheets per hour, a standard gift box job that was created from zero to production in minutes, and another new complex decoration job that was created according to your feedback. All happening immediately as it should. We are here live, you are seeing us in front of your computer using technology. We have created jobs using the latest technology, digital technology. And we believe that the Highcon Beam is in the right place and the right time. Okay, so I need to guess, but we have 3 locations around the world. We have the USA one, we have in Sweden, we have in the Netherlands, and we have in UK. And actually we have 3 words: Jan Westerberg, probably a name, Graphicus, and love. I vote for love. This machine, the Highcon Beam, is ready to go out. We are now in final stages of development of the machine that was launched in Drupa 2016. And actually when we launched it in Drupa, we had a huge success. And we are ready to ship first units of this machine this year and much more in the coming year, in 2017. But actually, the Highcon Beam is already at a customer site. It's already been beta tested at Glossop Cartons in the UK. What it means beta testing? We have more work on this machine. We know it's not ready to ship out to commercial installation. But Brian Sidebottom, who was one of the first users for the Euclid with Glossop Carton, his company, is actually the one with most expertise and most knowledge on the customer side of Highcon. So he was the first to take this machine, implement it in his factory, providing us feedback that is valuable for us, for our development, but also is valuable for you, because there is only a certain extent that we can take development in our labs. At some point, we need our customers to test the machine. And this is exactly what Brian is doing. So now, finalizing the demo of the Highcon Beam, I hope you enjoyed it, and this is the machine that is ready to ship out. We'll take a quick break, 3 minutes, and then we'll join in Brian, who can tell you more about his experience with Highcon, the Euclid, and the Beam. So, hello again. I'm being told that we have lots of questions and we will be happy to answer all of them. What we would like to do now is bring over Brian. Brian, can you hear me?
Yes, I hear you fine.
How are you, Brian? Thank you for joining.
I'm good, thank you very much.
Did you watch the demo?
I did, straight through. I do it every day.
How was Moti?
He's okay as an operator, not too bad, not too bad. Perhaps maybe get the speed up a little bit of the mate ready.
We'll send him over to you for training. Can you put on the questions a bit? One of the first users of Highcon technology, and this is why we wanted you to join today. First, start by telling us a little bit about you and your company, Glossop Cartons. Brian? Brian, can you hear me? Hold on, we'll get Brian in a minute. So I will start until we have Brian to show you one of the nicest examples actually coming from Glossop Carton. One of the first jobs that Glossop Carton did with the machine is demonstrating one of the unique capabilities of Highcon's machine. As you saw, we separated cutting and creasing, which allows us to achieve what we call cut on crease. You can actually crease and cut on the same area, on the same edge, for example, in this case. And when this was released to the market, it was a huge revelation because it was the first time that you can actually cut on crease. And this is one of the examples, one of the first jobs that Brian and Glossop Cartons manufacture that actually won them many awards. Not because it's a nice box, it is a nice box, but because of the novelty of the fact that you can actually do things that were impossible today with an analog machine. So I see Brian. I want to know if you can hear us.
I can hear you fine.
Great, Brian. So again, tell us a little bit about Glossop Carton and your company.
Okay, so Glossop Cartons were founded in 1982, about 34 years ago. So there was my father-in-law, my now wife, and myself, and we were the main founders. We traded for about a year, and then unfortunately, age 47, my father-in-law died suddenly, which was a massive shock. It meant that Jackie and I then took over the running of the business. We worked crazy hours for many years. We brought up a family along the way. But once things settled down a little bit, we created steady growth over quite a few years. And then over the past 8 years, we've got far more aggressive. We've purchased 2 other companies and brought them both into one company. We've also had a massive investment plan, which of course Highcon have been part of. So now we have new premises, and we are now quite a reasonable sized mid-range company.
Okay, thank you, Brian. And what about Highcon? When did you learn first about Highcon? What was the history?
We went to Drupa 2012 mainly to look at digital print and to investigate whether we could utilize that and become perhaps one of the first carton companies to digitally print cartons. But we'd heard about the Highcon stand and digital cutting and creasing, so we decided to go and have a look and see what was happening. We got to the Highcon stand just as a demonstration was finishing, so we saw the last maybe 30 seconds of the demonstration, and of course then everybody was very busy on the stand, etc., and we never really got a chance to speak to anybody. But we looked at the samples that had been cut and thought, yeah, okay, it's interesting technology, but hey, it's not quite there yet. The creases were good, but not equal to what we'd expect of an analog machine. And the cutting, we had a few brown marks around the outside, so it was sort of one of those we put aside and thought, maybe a couple of years' time, then this is perhaps something worth looking at again. Then we had Mark Nixon a few months later from Conversion, who's your channel partner in the UK. He came, brought the same cartons, where the creases were, oh, this is spectacular. The creases are good, the folding nice and neat, very sharp, very square, virtually no browning around the edges, and it was like, okay, so this is really interesting now. We went over then the beginning, probably mid-January, I think, of 2013. We had a demonstration done. We looked at it. Basically, we placed the order there and then and became the first Euclid owners in the world.
And Brian, it's interesting because you said you were looking into digital printing and you went to digital cutting and creasing. What was the deciding factor besides the quality? What was the reason that made you go to the Euclid?
There was only one real reason. The Euclid was the only thing that could actually do real creases. I mean, we'd seen other laser cutters, they were just coming into the market at the time, but everything involves scores or partial cuts for the creases. And this really is not acceptable in mass market cartons. Everybody wants a nice, smooth, good quality crease. The Euclid was the only thing there that could actually come up with the goods.
And usually people decide this going digital because of short run. This is the major factor. How do you see short run? What do you define as short runs?
Yeah, well, it's an interesting question really, because short run we would see as being anything from maybe, well, back then probably 1,000 cartons upwards, maybe 500 cartons up to maybe 2,000, something like that. But with the advent of buying the Euclid, we now consider short run being as low as 8 cartons, I think is the smallest we've ever produced. Generally though, 200 cartons up to 2,500. But having said that, 2,500 is by no means the limit. We've been on jobs and produced tens of thousands of cartons.
On the Euclid, right? The tens of thousands, or on the Euclid before the beam?
On the Euclid, yeah.
And actually, how do you decide today what kind of jobs go to the Euclid and what goes to the analog standard process?
Euclid, the first one is quite easy. A lot of the jobs that we do cut, they're cut on the Euclid because they are impossible to cut conventionally. So there's only the Euclid that can do it. Other reasons are short run. Obviously, if somebody only wants 250 cartons, then they don't want to buy the tooling, which could cost several £100s. Also, there are people that don't want to wait for the tooling. So, hey, we need some cartons desperately. We've just realised we've run out, or whichever way it's gone, and we want some tomorrow. Not a problem. We just have the DXF file, the CAD drawing, load it up, and as everybody's seen, just load the file and run the job. It is that simple.
And if you need to describe or to try to analyze what was the impact that the Euclid had on your business, what would you say?
At first, it was a very strange sort of effect, because we had this vision that all of a sudden all these orders were going to come flooding in. It didn't really work like that. Because we were the first in the world, nobody knew about it, first of all. But then we found that customers now find us We've even got cutting form manufacturers now sending us customers where they've been put a design in front of them saying, can you make me a cutting form for this? They say, no, it's impossible. You need to go to Glossop Cartons because they can cut anything.
So the answer to my next question, did the Euclid got you new customers, essentially is yes.
Spoiled your question there, didn't I? Yes, definitely. New customers. It's also given us the ability, because we've grown and grown and grown, we were losing the ability to do small run cartons because we've invested heavily in heavy machinery for high production runs, and it left us the small end, which is where we started off specialising in, really becoming more of an irritant almost, because it was becoming very difficult to produce, and it's hard sometimes when you're running a 50,000, 100,000 sheet run, just squeeze a short run in that's maybe only 200 sheets. It becomes difficult. So all of a sudden, we had this ability to be able to do the short runs very, very easily, and also no tooling storage, things like this. It made everything cheaper and for the customer and easier for us to produce.
And then, Brian, taking you in time, almost 3 years later, you decided to be first again with the beam. What made you make this decision?
Well, we were fortunate that Highcon came to us and gave us the offer to initially be the beta testers of it. But realistically, as we've watched the Euclid develop over the last 3 years, one of my favourite sayings is one day most cartons will be cut on one of these machines. And I truly believe this. The beam is just the next generation, it's going faster, and I'm looking forward to it entering full production with us here, and then also the next step is what's going to come next, because the next machine will be a mainstream machine, I think.
And today it's no secret, you have the Euclid and the beam is now in beta. You have analog printing, digital printing with the Highcon machine, and you have analog cutting. So you have a mix of workflow solution that enables you different combination. How do you manage it on a day-to-day? What is the differentiation factor between this type of combination or that type of combination?
The first rule we have is there are no rules. We'll take a litho printed job and digitally cut it. We'll take a digitally printed job where we've done maybe 11,500 sheets and analog cut it. The first thing is just to open your mind, and I think this is what we did when we bought the Euclid at first. It's just, you've got to let anything go. It's whichever suits. Some jobs are just only can be cut digitally because there's no other way. But certainly with the advent of the beam and the beam coming into full production, we see it more of a crossover machine, because yes, it will still be cutting digitally cut work, but with the speeds it will run, then we're going to be looking at putting more and more normal litho work, because the volumes it will produce are where we would look at maybe limiting generally a 2,500, 3,000 sheet run, which we would say was the shorter end of the market on the Euclid. We're now looking at 5, 7.5, maybe 10,000 sheets being the upper ceiling for the beam, which is a massive step forward.
Definitely not short runs. So Brian, last question from me, because we open it up to questions that we have from the audience. How do you see the beam changing your business strategy in, say, the next 3 years?
I think the beam will make us far more reactive, first of all, where, again, because of the type of machinery we've invested in generally in the main factory, it's made us more, how shall we say, more sluggish. When you're running these large jobs, you can't just stop them and take them off. I would hasten to add, one of the things that you haven't pointed out is the fact that how easy it is to just stop a job, run a few sheets on the beam or the Euclid, and then just go back to your original job. You can do some crazy things like that, and there are no time costs overheads, basically. So generally speaking, I think with the beam, it's just going to make us faster at turning round jobs, faster at taking a job on board and saying, yes, there you go, there's the cartons within, well, in some instances, we've actually produced cartons within 24 hours, printed, cut, and delivered. So I think it's going to change things radically.
Sounds exciting and different than what you would anticipate. So I'm being told that we have tens of questions from all over the world, which really demonstrate the fact that we did have over 300 people from almost every country in the world that is connected to internet. And let's try and see what are the top questions that we got. And we're actually taking the questions that were sent to us through our website and from the different sites and trying to make a comprehensive list. If you had the questions and we won't have time to answer, or Brian will not have time to answer, it's okay, you will receive an answer by email. By the way, one thing that I didn't mention, that if you want to see examples of the jobs that we cut today, you can actually go on our website. I don't know if it's on my right side or left side, it's on your right side, and click send me a digitally cut and crease sample. And then questions that you might have about quality, you can see in your own eyes. It's very easy, very convenient using our website. Okay, so we have some technical questions. I don't think we will focus on technical questions. There is one question for Brian. Actually, Brian, the question is to you. How do you deal with questions from your customers about the quality of this new process? Do you see a challenge convincing customers to use this new technology? And if they have this question, how do you deal with them?
Yeah, it's a good question. And many customers are quite accepting about the new technology, and they don't see it as being a problem, especially when we're saving them maybe 300 to 600 pounds on tooling. All of a sudden it becomes much more appealing. There are ones that really are difficult, shall we say. Not everybody shares the vision perhaps at this moment in time. However, there's quite a few of those now that are turning. I think, generally speaking, I would say 95% of our customers are very accepting of the new technology. The creases are different. They aren't the same. They behave exactly the same. It's just the fact that they're manufactured differently. And I think these are the problems that some people have, shall we say, trying to understand. There's a certain amount of distrust in technology, perhaps, but no, like I say, we produce millions and millions of cartons off our Euclid, and everybody, bar one, I think, is happy. And to be quite honest, the one that wasn't was their own doing. It certainly wasn't a machine defect or a...
Thank you. Thank you, Brian. One question that we got from different locations is what other substrate we can run on the machine. And actually, our machine has such a huge range of application and paper gamut, going through paper, paperboard, and even microfluid. But we do not run synthetic substrates. We do not run new types of materials that are not paper or paper-based. We want to focus our efforts and our technology on paper. Why is that? We believe that this is our expertise. We know paper, paperboard, and we know our technology has a lot more room to grow. But in cases where you have some kind of elements like laminations, metallized laminations, for example, we can cut. But going into specifically cutting plastic or plastic-based application is not a part of our strategy, at least until not we become the predominant mainstream method of cutting and creasing for paper and paperboard. We have a lot more to contribute to Brian and companies like Brian and commercial printers before we go to the next type of industries and next type of substrate. So in a sense, paper and paperboard is in our core and in our focus. Okay, so another question for me again is what kind of parameters we can change when we crease? How we can define different creases for different substrates. So overall, we run a single type of creasing process, but we have many parameters that we can control. We can change different pressure amounts of the creasing to compensate for different types of substrate. We can also change a little bit in the algorithm, the writing process. For example, having a different creasing process in the machine direction and in the cross-machine direction. And actually, the fact that the process is digital, it means that with the same set of configuration, just controlling different elements of the definition of how the machine performs, we can adjust for different substrate. But actually, what we found out, that for the majority of substrate, the specially designed dart process that we did, perform the same results with a slight deviation of different pressure for different thicknesses. But our customers are finding the ways on the machine to optimize the process per substrate type. It doesn't need to be adjusted per job. Once you have the profile of creasing and cutting for a specific substrate type, it behaves the same for all of the jobs on the same substrate. Another question from the audience is about type of file that is needed to be compatible with our process. So actually what we decided when we announced and launched digital cutting and creasing to stay in the standard of the industry. And we actually use the standard DXF CAD files that is sent today to a die maker. And the machine receives the same standard file that will today be used to create an analog die, and from it creates the digital process. Okay. Another question is about the lifetime or the lifespan of the creasing rules. Remember, for each job, we create a new crease rule on the machine. And in the case of the beam, a single dart foil with creases can last for 20,000 impressions. So even a very long job, Brian mentioned 10,000, even 20,000, you can use the same crease rule. Once you complete the job, the foil is not reusable. When you take it off the machine, it's done. You need to create a new plate for the next job. Why is it important? We have this question all the time. In a digital mindset, Brian mentioned it, you don't want to store jobs. You don't want to have a warehouse. You don't want to have an inventory. You don't want to have an offline setup process that then you need to adjust again. You need everything to be stored on the file, created in a click of a button in a very fast way. So this is very critical for us. Okay, actually now Brian needs to leave. Brian, thank you very much for taking the time and sharing with us the information. And looking forward to visiting you, seeing the beam in action. And of course, you're welcome to Israel whenever you would like.
Thank you very much. It's been a pleasure.
Thank you. Okay. Another question? Okay. Okay. We had a question about the stripping system. Actually, the stripping is a special process that we developed. We call it the Highcon Integrated Digital Stripping Unit. We have stripping embedded in most of our machine at customer site, and you can go to our YouTube channel and watch a special video on the process of stripping. Actually, what we do is we use a unique kind of brush system combined with vacuum sucking, which can actually release even very, very fine elements. And our customers are already using that to create unique application. So this is a job, a real job from a customer side with very intricate cutting. This job was impossible without our cutting technology, but without stripping, there will be no way to clear all the residue. Another job from a customer in Italy is a very, very complex packaging for wine, for luxury wine or champagne, with a lot of intricate cutting. Of course, if this would need to be stripped manually, it will be very, very time-consuming and expensive, and there is no stripping tool that can clean out such delicate cutting and fine elements. Okay, another question from the audience from a live location. The final question is how many customers we have around the world. So actually, before Drupa, we said that we have over 25. After Drupa, we are now installing more and more machines around the world, and we have well over 30 installations. Actually, just a few days ago, we announced the first installation in Germany in a company called Hein-Warpackung, which brings us to Germany, and we have more and more installation all over the world, in Asia, in the USA, in Europe, and basically we cover now a wide range of countries. We sold in Drupa many machines to many new countries, so you will see in the future more and more Euclid machines being installed in different sites around the world. In addition, the Highcon beam is shipping out soon, and we'll have more installation on top of Brian, which is beta testing. And finally, next year we'll introduce an additional machine to our portfolio, the Highcon Pulse. Digital cutting and creasing for B2 29-inch workflow to work hand in hand with the digital printing machine. So actually our time is over. I wanted to thank you, really, this is a very exciting event taking the use of the technology to communicate with hundreds of people all over the world. As you know, doing such event is a high risk. You see me, but I do not see you. And we like in Highcon to take measurable risk. We want to act fast and we want to innovate and use the latest technology. This is why we're doing such things like this live event. So really, I thank you for joining in. If you have more questions, if we didn't answer the questions, we'll answer you personally via email. You can continue writing us questions. You can approach us by our website. You can order a sample to watch the quality. And you can watch our YouTube channel, our video page in our website. You can go to our Pinterest board and see the wide range of applications, the wide range of stories and capabilities that we are delivering and that our customers are using, and more important, that brands are using around the world. So thank you very much, and look forward to seeing you in the next Highcon event.